We've been hearing about solid-state batteries for over a decade now. For years, especially Toyota, they've been tweeting lots of tweets and saying that they're coming next year.
What if Toyota's biggest weapon in the EV race isn't a new car, but a battery that could change the rules completely? While competitors chase electric sales, Toyota has been quietly building a different strategy around hybrids, EVs, and one potentially game-changing technology: solid-state batteries. The company is targeting around 1,000 kilometers of range and a 10-minute charging time, numbers that could transform long-distance driving if they actually reach production. But there's a catch: high costs, difficult manufacturing, durability concerns, and years of delayed launch dates still stand in the way. So, is Toyota finally about to leap ahead, or is this another promise still waiting to become reality? Let's find out. Toyota's EV strategy explained. Here's the thing about Toyota that confuses a lot of people. When you look at pure electric vehicle sales alone, the company looks almost timid. In the first half of 2026, Toyota sold around 190,000 fully electric vehicles worldwide. That's actually a solid jump.
The first one at 10,000 miles. Now, as far as insurance costs are concerned, they're okay with this product. About $1,800 per year.
About 35% more than the same period last year. But put that number next to the fact that Toyota sells more than 10 million vehicles a year, total, and 190,000 suddenly looks tiny. We're talking about a sliver of the company's overall business. So does that mean Toyota is losing the EV race? Not exactly, because pure EVs aren't the whole story Toyota is telling. Zoom out, and Toyota groups hybrids, plug-in hybrids, and full EVs together under one umbrella term: electrified vehicles. And when you look at that bigger bucket, the picture flips completely. Toyota is now selling more than 5 million electrified vehicles a year. In just the first half of 2026 alone, that number already passed 2.7 million, more than half of everything Toyota sold in that period. Sit with that for a second. Every second Toyota vehicle rolling off a lot right now runs on a battery in some form, hybrid or fully electric. That's not a company ignoring electrification. That's a company betting on a different road to get there. Regionally, the story gets even more interesting. In Europe, Toyota's EV sales have more than doubled in some markets. People there are adopting electric vehicles fast, and Toyota is riding that wave along with everyone else. In the US, EV sales roughly doubled too, landing around 22,000 units in the first half of the year. Small compared to Tesla's numbers, sure, but real, meaningful growth. China is where things get tougher, and it's worth being honest about it. Local manufacturers are cranking out capable, aggressively priced EVs, and Toyota is genuinely struggling to keep pace on both cost and speed of innovation there. That's the one major market where Toyota's electric ambitions are clearly lagging behind the competition. So what's the actual plan here? Toyota calls it a multi-pathway strategy, and honestly, it makes more sense than it sounds on paper. The company's argument is simple. Not every country is ready for the same solution at the same time. Some places barely have charging infrastructure. Some places have brutally long driving distances between cities. Some places have expensive electricity that makes charging less appealing than it should be. So instead of forcing pure EVs on every market at once, Toyota is leaning on hybrids where they make practical sense today, while steadily scaling up full electric vehicles wherever the infrastructure and demand actually support them. Toyota's stated goal is to hit annual EV sales in the millions by 2030, with some reports pointing to a target of 1 million or more pure electric vehicles sold every year by then. But right now, hybrids are still doing the heavy lifting for the company. They sell easily, customers trust them, and they're genuinely profitable. And what about the electric vehicles Toyota does sell today? The flagship is the BZ series. You might know it as the BZ4X, though some markets now just call it the BZ. Range depends heavily on where you're buying it, around 480 to 500 kilometers officially in the US, and up to 550 to 600 kilometers claimed in Europe. Real-world driving trims that down a bit, usually landing somewhere between 450 and 550 kilometers depending on weather, speed, and road conditions, which, if you've owned any EV, you already know is just how range numbers work everywhere. Toyota has also been quietly upgrading the battery and motor in these vehicles, closing a performance gap that used to be genuinely embarrassing compared to competitors just a couple of years ago. It's worth pausing here, because this is the part most headlines skip entirely. Toyota isn't slow because it's confused about where the industry is heading. It's slow by design because it's betting that a straight sprint to pure EVs everywhere, all at once, isn't actually the fastest way to cut emissions or win customers globally. Whether that bet pays off depends almost entirely on what we're about to talk about next, because a battery breakthrough is exactly the kind of thing that could let Toyota leapfrog straight past the slow and steady phase of this race. So that's today, a company that looks conservative on paper, but is clearly moving with intention underneath the surface and building towards something much bigger. Which brings us to the actual headline. What is Toyota really doing with the battery itself? The secret inside the battery. Before we get into the wild numbers everyone's excited about, let's actually understand what's changing inside this battery. Because solid state gets thrown around so casually these days that it's basically become a buzzword. Here's what it actually means. Every lithium-ion battery in an EV today.
China's dominance in global lithium-ion has sparked companies worldwide to recharge their own efforts in battery technology, from new chemistry to production technique.
Tesla, BYD, Toyota's current BZ, doesn't matter who makes it, works on the same basic principle. Inside the battery, there's a liquid material called an electrolyte. Its job is to let charged particles, ions, move back and forth between the two sides of the battery. That back and forth movement is literally what makes the battery charge and discharge. Liquid electrolyte has worked well enough to power the entire EV revolution up to this point. It's mature technology, it's well understood by engineers everywhere, and it's manufactured in the millions every single year. Toyota's current EVs, like the BZ series, use a version of this liquid lithium-ion battery in what's called a prismatic shape, basically flat and rectangular, stacked efficiently to save space. Some of the newer packs also use something called a bipolar structure, which packs more power into less physical space, while keeping weight down. Meanwhile, older Toyota hybrids, think classic Prius models, have long relied on a completely different technology called nickel metal hydride. That tech is old, but famously tough, reliable in extreme heat and cold, and known for lasting years without much drama. Even so, Toyota has been gradually shifting its hybrids toward lithium-ion as well.
You're choosing between lithium-ion and lithium-ion. Today's EV batteries use liquid inside the cell to move energy around.
Simply because it's lighter, more powerful, and charges faster than the older nickel-based batteries. But liquid electrolyte, for all its maturity, has real downsides. It's part of why current batteries are as heavy as they are. And it's part of why they can be genuinely dangerous if something goes wrong. Liquid electrolyte is flammable, and if a battery gets damaged or overheats, that liquid is a major contributor to the fire risk you occasionally hear about in EV crash stories. Here's Toyota's move. Take that liquid out entirely and replace it with a solid material instead. Specifically, the version Toyota is developing uses a solid electrolyte made from sulfide. The ions still move from one side of the battery to the other, same basic physics as before, except now they're moving through a solid instead of a liquid. Why does that matter so much? Two big reasons, and they're the reasons this whole story exists. First, energy density. A solid electrolyte lets the battery pack more energy into the exact same amount of physical space.
Solid state replaces that liquid with a solid material. That change alone can allow for more energy in the same space, better safety margins.
Think of it like the difference between loosely tossing clothes into a suitcase versus vacuum sealing them. Same suitcase, dramatically more fits inside. That directly translates into more range, without needing a bigger, heavier battery pack strapped under the car. Second, safety. Without a flammable liquid inside, the risk of leakage and overheating-related fires drops significantly. That's not a minor footnote in an engineering report. It's one of the most legitimate fears people actually have before buying an EV, and solid-state batteries are expected to meaningfully improve on it. So if it's this much better, why hasn't every automaker just switched over already? Because building it is genuinely brutally hard, and we're going to get into exactly why in a few minutes. But first, let's talk about the numbers everyone actually came here for. How far can this thing go, and how fast can you charge it back up? The battery that could win. Okay, here's where it gets exciting. Toyota's target for the first generation of its solid-state battery is roughly 1,000 kilometers of range on a single charge. That's about 620 miles, for context. And Toyota isn't stopping there. The next generation is already targeting around 1,200 kilometers. Let that actually sink in for a second. Most EVs on the road today, including Toyota's own BZ series that we just talked about, deliver somewhere in the 400 to 550 kilometer range. Toyota's solid-state target is nearly double that. We're talking about a vehicle that could realistically drive between two major cities hours apart without a single charging stop in between. Now, a fair caveat here, because we're not in the business of overselling things on this channel. The actual range you'd get in a real car will still depend on the vehicle's weight, size, and how aggressively it's driven. A heavy SUV isn't going to hit the same numbers as a lighter sedan, full stop. But even accounting for that, Toyota's target puts premium EVs, and Lexus specifically, is expected to be among the very first brands to actually get this battery, within real reach of that 1,000-kilometer mark. Then there's charging. This might honestly be the number that changes people's minds even faster than range does. Toyota's target is charging from 10% to 80% in about 10 minutes. 10 minutes. That's roughly the time it takes to order a coffee, wait for it, and check a couple of messages on your phone. Compare that to today's reality, where most EVs need 30 to 40 minutes, sometimes considerably longer, for the exact same job. If Toyota actually hits that number, charging stops being, let's plan our whole road trip schedule around this, and starts being, let's just grab a snack while we wait. Try to picture what that actually looks like in daily life. Say you've got family a genuine road trip away, 6-7 hours by car, the kind of drive people take for a long weekend. Today, that trip in most EVs means at least one real charging stop, sometimes two, each one eating 30 to 40 minutes out of your day. With a 1,000-kilometer battery and a 10-minute top-up, that same drive could realistically happen with 0 mandatory stops, or maybe one quick coffee break charge if you're being cautious. That's the difference between an EV feeling like a compromise and an EV feeling like just a car. And then, safety, the quieter benefit, but arguably just as important as the other two. Because there's no liquid electrolyte inside a solid-state battery, the risk of leakage drops, and so does the risk of the kind of thermal runaway that leads to the battery fires you sometimes see in the news about today's EVs. Toyota has spent years accumulating patents specifically around this technology.
If Toyota's hybrids weren't already in crazy demand, it's about ready to get better or worse, depending on how you look at it. Better from Toyota's perspective because these new hybrids.
And a big chunk of that research isn't just about squeezing out more range. It's about making the battery lighter, faster charging, and safer, all three at once, without one improvement coming at the cost of another. Put those three things together, range, charging speed, and safety, and you can see why this isn't just another incremental battery upgrade dressed up as a big deal. If Toyota actually delivers on these numbers, it directly attacks the two biggest objections people bring up when they're on the fence about buying an EV. I'm worried about running out of charge somewhere, and charging just takes forever compared to filling up gas. Solve both of those at once, and you've removed most of the psychological barrier that's currently keeping a huge chunk of drivers on the sidelines. But, and this part is genuinely important, none of these numbers exist in a customer's driveway yet. Not one. Not a single regular customer is driving this battery today. So let's talk honestly about why, and what's actually standing in the way. The problems Toyota still faces. Here's where we need to pump the brakes a little, because it would be irresponsible to hype you up on this technology without talking about what's actually standing between Toyota and your driveway. Problem 1. Cost. Right now, producing a solid-state battery is expensive. Early estimates put it at roughly 3 to 4 times the cost of today's lithium-ion batteries. That's not a small gap, and it's exactly why Toyota's plan is to launch this technology first in premium vehicles like Lexus, where buyers are already used to paying a premium for cutting-edge tech. Costs are expected to come down significantly over time, but only once production actually scales up, and that scaling up is problem number 2. Manufacturing a solid-state battery at scale is genuinely difficult, in a way that's easy to underestimate from the outside. The solid materials inside have to be made extremely thin and incredibly precise. Even a small manufacturing mistake can render an entire battery defective. And right now, the defect rate, the percentage of batteries coming off the line faulty, is still high. Making a handful of these batteries carefully in a controlled lab environment is one thing. Making millions of them, consistently, at an acceptable failure rate is an entirely different engineering challenge. It requires new specialized machines, new quality control processes, and a manufacturing learning curve that simply takes real time to climb, no matter how much money you throw at it. Problem 3. Durability. How long will these batteries actually hold up through years of repeated charging and discharging in the real world? Early testing has shown that some solid-state batteries can develop internal cracks or lose power over time with continued use. Toyota says it has found solutions to this specific problem. But here's the honest truth. Nobody will really know for certain until these batteries have been living in real cars, in real driveways, under real conditions, for several years straight. And buyers are going to expect these new batteries to last just as long as today's do, 8 to 10 years minimum, before they'll trust them the same way they trust a regular lithium-ion pack. And then there's problem 4, the one that should make you a little healthily skeptical: timing. Toyota has been talking about this technology for a long time, and the target date keeps sliding. At one point, the industry was hearing 2020 as the launch window. Then it slipped to 2025. Now the target is 2027 to 2028. That's not necessarily a red flag on its own. Genuinely new battery technology is hard across the entire industry, not just at Toyota, and delays are almost the norm rather than the exception. But it does mean you should treat any specific launch date with a healthy dose of skepticism until actual cars are actually shipping to actual customers. Here's what makes this round feel a bit more credible than the last one, though. Toyota isn't just talking this time, there's real infrastructure behind the announcement. The company has secured formal production approval from the Japanese government. It's building an electrolyte production plant together with partners, targeted for completion by the end of 2027. Company executives are publicly saying they're on schedule. That's more concrete, verifiable progress than we've seen attached to any previous announcement about this battery, but it's still not a car sitting in a driveway, and it's worth remembering that. So where does that honestly leave us? Somewhere between genuine excitement and cautious patience. The technology is real, the progress is real and measurable, but so are the obstacles in front of it, and they're the kind of obstacles that take years to solve properly, not months. It's also worth remembering that solid-state batteries have been almost here across the entire industry for years now. Multiple companies, not just Toyota, have promised breakthroughs that then quietly slipped by a few years. That history doesn't mean Toyota's current progress isn't real. It just means the smart move, as a viewer and as a potential future buyer, is to watch for actual production vehicles rolling off actual assembly lines, not press releases, before treating any of this as a done deal. Which raises the next, and honestly more interesting question. If Toyota does pull this off, even a little later than currently planned, what does that actually mean for everyone else in this industry? Toyota's battery could change everything. Let's play this forward for a minute. If Toyota actually gets a roughly 1,000-kilometer, 10-minute charge battery into real cars, even starting small, in a limited premium rollout, what happens to the rest of the industry around it? Start with Tesla and BYD, the two biggest names in electric vehicles today.
Tesla has lost its position as the world's car maker. BYD is now in top spot after its sales rose by nearly 28% last year to 2.2 million.
Tesla has built its entire identity around range and technological leadership. BYD has grown explosively, especially in China and increasingly elsewhere, largely by offering strong EVs at genuinely aggressive prices. A Toyota battery with nearly double the range of today's average EV puts real pressure on both of them. Not necessarily because customers abandon them overnight, but because the bar for good enough range and charging just permanently moved upward. Tesla is already working on its own next-generation battery technology, but Toyota entering this specific race, with this specific breakthrough, raises the stakes for everyone considerably. BYD, for its part, is also actively researching solid-state technology of its own. But if Toyota genuinely gets there first, BYD may be forced to accelerate its own timeline just to avoid looking like it's falling behind in a race it's currently winning on price. Honda is arguably in an even more exposed spot. Honda has already publicly committed to bringing solid-state batteries to its own vehicles within the coming years. If Toyota beats them to market, the pressure on Honda ramps up almost immediately, because once one major Japanese automaker proves this technology actually works at commercial scale, customers everywhere start asking uncomfortable questions of everyone else. Why does this company already have it, and you still don't? That kind of pressure doesn't stay contained to Honda alone either. It spreads outward to other Japanese and Korean manufacturers quietly working on similar technology behind the scenes. The entire industry posture shifts, almost overnight, from "we're preparing for the future" to "we need visible results now." Then there's the market share and pricing angle, which is where this gets really interesting for regular customers. The EV space is already brutally competitive, and if Toyota can genuinely deliver long range paired with fast charging, it's going to attract a very specific kind of customer. People who drive long distances regularly and who've been sitting on the sidelines specifically because of range anxiety and charging time frustration. Pulling those customers away from Tesla or BYD, even partially, forces a response. Either competitors cut their prices or they pack in more range and features at the same price point just to stay competitive. BYD's core strength has largely been affordability.
The BYD Atto 2 is a new Chinese electric SUV with a low starting price, a karaoke machine, and a name that actually makes sense.
So in the premium segment specifically, Toyota's new battery could become a genuine, direct threat to how Tesla positions itself against everyone else. And it's not just the giants who feel this shift. Smaller manufacturers, still leaning entirely on older battery technology, risk falling meaningfully behind if the broader industry pivots towards solid state. Expect to see more partnerships forming between automakers and dedicated battery specialists, and more direct investment pouring into in-house battery research, as companies scramble to avoid being caught holding yesterday's technology while everyone else has moved on. There's also a bigger, quieter ripple effect worth mentioning: supply chains. If solid-state batteries genuinely take off, demand for some of the raw materials used in today's liquid lithium-ion batteries could start to shrink.
Let's simplify this. Today's EV batteries use liquid inside the cell to move energy around. Solid state replaces that liquid with a solid material.
While demand for the new materials solid-state batteries actually need, like the sulfide compounds Toyota is using, starts climbing fast. Companies that built their entire business around sourcing and processing yesterday's battery materials could find themselves scrambling to adapt. But, and this part is worth repeating one more time, all of this domino effect only really kicks in if Toyota hits the mark. Right price, right performance, right volume, roughly on the schedule it's currently promising. If the rollout gets delayed again, or the price stays too high for too long, the disruption across the industry will simply be smaller and slower to arrive. Even so, expect competitors to accelerate their own solid-state plans regardless, purely as insurance, just to avoid getting caught flat-footed if Toyota really does deliver on time. So the real question hanging over this entire industry right now isn't just, can Toyota actually build this battery? It's what does everyone else do the moment Toyota proves that it can? So where does this leave Toyota? Sitting on a battery that could genuinely rewrite the rules of electric driving. 1,000 kilometers of range, 10-minute charging, real government approval, and a factory already under construction. But also years of delays, sky-high costs, and manufacturing hurdles nobody's fully solved yet. If Toyota pulls this off, Tesla, BYD, and Honda won't have a choice but to respond fast. If it doesn't, we'll be having this exact conversation again in a few years. Either way, the EV race just got a lot more interesting. So, is Toyota finally about to leap ahead, or is this another promise still waiting to become reality? Tell me below and subscribe to find out.